Hey everybody, today we're going to take a look at some rational expressions. So first of all, I don't even know what's happening with this, sorry. This is not rational exponents, don't know what that is. Well, I do, but that's not what we're doing. We're doing rational expressions. And it's also not unit 6, it's unit 5, so let's get that fixed. When you do this, if you can factor, you should factor. And if you can't, just start dividing. So when you divide numbers, of course, make sure you divide like 3 goes into 3 once and 3 goes into 12 4 times. So now we have a 4 on the bottom. And then you subtract your exponents. No exponent is a 1. So 2 minus 1 means we have x to the first. Now, we have an issue with the denominator. And that is the denominator is not allowed to equal 0. And it's real easy to just focus on your answer. But you have to focus on the entire problem from beginning to end. All denominators have to be looked at. So this denominator, of course, our answer, has no variable in the denominator. Don't have to worry about it. But the original one does. So we say, okay, there's my denominator, and it's not allowed to equal 0. Divide both sides by 12, and we get, of course, 0 on top is 0. X cannot equal 0. So even though there's no letter in the answer in the bottom, it doesn't matter. You have to go back through the whole problem. So when we divide this one doesn't divide out real nice, but that's okay. 3 goes into 42 14 times, and 3 goes into 9 3 times. So now we have 14 and a 3. And of course, we're going to subtract the exponents. 7 minus 1 puts x to the 6th on the top. So the problem is finished, but then we have to go back to the original denominator because there's a letter in that. Anytime there's a letter, any letter in the bottom of the fraction, you have to take a look at it. So 9x is not allowed to equal 0. And once again, we get x is not allowed to equal 0. So the entire answer is not just the reduced fraction, but also all domain restrictions. You have more than one letter, you have more than one restriction. On this last one here in this little group, 4 goes into both of these numbers. So, of course, we can reduce that. That would be a negative 4 over 3. As far as the x's goes, now when you subtract these, your answer goes where there are more. So there are more in the bottom, and there are 3 more in the bottom. So x to the third goes in the bottom. We're still subtracting. But you can't write a negative exponent. So that's a quick kind of shortcut to not have one. For the y's, y to the 7th minus y to the 3rd means y to the 4th is on top. And there is no other z's to subtract, so z to the 4th stays on the bottom. Now, the denominator. 12x to the 5th, y to the 3rd, z to the 4th is not allowed to equal 0. We can divide both sides by 12. And then we get only these letters, which really it's hard to know. What do we do with this, right? And basically, if you're multiplying, what that means is that x is not going to be able to equal 0, right? Because that's can't be in the bottom. Y also cannot equal 0, and then of course z cannot equal 0. We have 3 letters. We have to come up with a domain restriction for all 3 that appear in the denominator. If we have adding or subtracting in the top or the bottom or both, then that means you have to factor. Don't just start crossing off stuff. Don't just make everything match. Oh, this x's match and this goes, and you can't, no, it doesn't work like that. It's never going to work like that. So you're better off. And of course, now I can't get rid of that. You're better off just not doing that. Please, please don't do that. Oh, I can undo it. There we go. So it's undone. All right, so we're going to factor. And then you list the restriction for the denominator. But remember, we have to go back through the entire problem. Every time the denominator changes, we could create another restriction. It's not that bad, though. Take out a 6 out of the top. That leaves you with x plus 4. Out of the bottom, we can take out a 2. That leaves you with x plus 4. Oh, look at that. x plus 4 match. Now you can cross those off because now this is a multiplication problem. It's not an addition problem. 6 divided by 2 is 3, so the answer is 3. But don't forget, 2x plus 8 is not allowed to equal 0. So 2x is not allowed to equal negative 8. And then x is not allowed to equal negative 4. And you might be thinking, hey, the answer's 3. X already doesn't equal 4. You gotta say it anyway. Sorry. Again, don't just cross off 3s and 12s, right? It's not a matching. It's a factoring problem. So the numerator factors out of 3, and you're left with x minus 4. The denominator can factor out of 3x, and you're left with x minus 4. Look at that. Gone, gone. Now the 3's cross off, and we only have a 1 in the numerator. Don't leave your top part blank. It's got to be filled in with the 1. The bottom part can be filled in or can be left blank, but the top needs a 1. So I'm going to go back to this part right here. I like this piece. The factored out part. Set your two factors equal to 0. This is generally going to be the easiest place to set, say, your domain restrictions. So 3x cannot equal 0. X minus 4 cannot equal 0. We do not care about the top. The top of the fraction is like a junkyard. So our domain restrictions are x cannot equal 0 and x cannot equal 4. So again, the top can get anything it wants. Absolutely anything at all. It's the bottom that you got to have. You're real picky. We don't want zeros in the bottom. We can have zeros in the top though. A little bit more complicated factoring. Now maybe you understand why we spend some time going over factoring. We need two numbers, and when you multiply, you get 12. If you need to make the list, do it. When you subtract these two numbers, you get a 1. So we're going to have x and x, and of course 3 and 4. In order to get a negative 1, we want this to be a negative 4 and a positive 3. On the bottom, we need two numbers that multiply to give you 8. Aren't very many. And when you subtract them, you get a 2. So that's also going to be a 4. I'll put that underneath there just for fun. And a 2. And of course, we want this to be a minus 4 plus 2 because we're trying to get a negative 2. Now we cross this out. So the answer is x plus 3 over x minus 2. But let's take the factored out denominator and say, okay, our parts cannot equal 0. Even the 1 that got crossed out. All of them, all the parts matter. Everything matters. So this gives us x cannot equal negative 2 and x cannot equal 4. So if you want to make a list, you can write x cannot equal negative 2 and 4. And you can just start listing the domain restrictions if you'd like. We're going to use the letter x because x goes with domain. Top part, two numbers, when you multiply, you get 4. But when you add them up, you get 5. So 4 and 1. And both of them will be negative. Because when that second sign is a positive, that means both signs match the first one. And the denominator is just general, plain old greatest common factor. They have an x in common, leaves you with x minus 4. I got something about x minus 4. I don't like x minus 4, apparently. So the answer is x minus 1 over x. And no, those two x's don't cross off because they don't match exactly. The top is subtracting. Subtracting and dividing don't undo each other, so leave it alone. Now we have x cannot equal 0, right? Again, I'm looking at this. And then x minus 4 cannot equal 0. So our domain restrictions are, of course, 0. And then when you add the 4, you get x cannot equal 0 and 4. This domain restriction stuff is with us until the end of school. Oh, good, some more factoring. I knew you were thinking that. When you multiply, you get 6. When you add, you get 5. 6 times 1, 2 times 3. Now, these can both give us 5, but we know we're adding because that second sign is a plus. So this has to be a 2 and a 3, and they're both going to be negative. That's a tricky one to factor. Bottom is a little bit easier. Multiply to get 15. Well, there's only two numbers, right? 1 times 15 or 3 times 5. So we want this to be 5 minus 3. X minus 3 is cross off. The way this works is anything on the top can cross off with anything on the bottom. It doesn't really matter where they are, as long as one's top and one's on the bottom. So the answer now is x minus 2 over x plus 5. Take all of the factors and say that they cannot equal 0. And so we get x cannot equal 3 and what? I'm sorry, I don't even know what I wrote there. Sorry about that. Let me get rid of all this. Backing this up. So right there, we're going to have x plus 5 cannot equal 0. And so our restrictions are x cannot equal 3 and negative 5. I don't even know what I was writing. Sorry. Woohoo, last one. Big finish. Here we go. That's my problem, is I don't know what my eraser looks like, so. Multiply to get 80. Ooh. 1 times 80. 2 times 40. 4 times 20. 8 times 10. I feel like 5 might go into it. I don't think we need that though. All right, because to get to the 2, 8 and 10 will work. So we know that works. So I'm not going to worry about the other factors. So x, and we know we have to use 8 and 10, and we want the 10 to be positive and the 8 to be negative, so we get positive 2. In the bottom, we have a couple things going on. We're going to take out a common factor, which looks like 2x. So we get x squared minus 12x plus 32. Now we need factors of 32. 1 times 32, 2 times 16, 4 times 8. I think that might be it. 4 and 8 works though, right? Because 4 plus 8 is 12. So now we're going to have x minus 8 times x plus 10. The bottom, the 2x is still there. It doesn't go anywhere. And now we write the factors. We know it's 4 and 8. And they're both going to be minus, because when we add, right, we add because the last is a plus, and the both signs match the first one. All that work and all that crosses off is the x minus 8. So the answer is x plus 10. You do not need to multiply this back out. Leave this like this. All right, so that's what we have left over. However, we have to take all three factors. 2x cannot equal 0. X minus 4 cannot equal 0. X minus 8 cannot equal 0. So we get x cannot equal 0, 4, and 8. Just move those numbers. So x cannot equal 0, 4, and 8. Factor and cancel, factor and cancel, factor and cancel. Please do that.